Hi everyone, welcome. In this lesson, we're going to take a look at piecewise functions, which is chapter 2, section 3 of our textbook. So this section starts off by looking at what it calls a library of functions. And what that means is it just looks at the different types of functions that we've learned about in the past. So for example, we have linear functions, line, we have quadratics, parabola, it looks at cubic functions, also square root functions, absolute value, and there's a few others. So it just kind of goes over a few of the functions that we've looked at in the past. Inverse is another one, where we get these two curves, 1 over x, and lists them all out. So it's kind of a review or a refresher of the different functions that we've dealt with in the past. The main part of this section is on piecewise functions. So piecewise functions have to do with graphing functions where we restrict the domain, and depending on the domain, our graph has a different shape. So the shape of the graph depends on what x values we're looking at. So it depends on the domain. So we're restricting the domain in some way. A quick example, we could have f of x equals, and then you'll often see a curly bracket, and all of the different functions throughout all of the different x values that we could encounter are going to be listed in these spots. So, for example, we might have f of x equals x squared plus 2. And then what you'll see is to the right, you'll see where in the domain we encounter this function. So x squared plus 2 if x is greater than 0. And then we might see another function, perhaps negative x minus 1 if x is less than or equal to 0. So depending on what x values we're looking at or what part of the domain, we have a different shape for our graph. So this graph would have two different shapes in it, two different functions. And of course, we can see we have a line for this part, and we have a quadratic up here. So to start with the quadratic, we know that a quadratic is a parabola. It's been shifted up 2. So we're looking at 2 on our graph. And we have a quadratic like that, so one arm of the parabola. And we have to pay close attention to this restriction on our domain. Here we have x is greater than 0. So this means for any x value greater than 0, anything to the right of 0, we have this parabola. When we reach 0, we don't actually look at the point on this parabola at 0 because we don't have an or equals to. So what that means, thinking about, for example, one variable inequalities, what that means is we have an open circle here at 0, 2. So our graph gets close to that open circle, but doesn't actually reach that open circle. When we reach 0, as we can see down here, we switch over to our line, and then anything to the left of 0 is graphed as our line, negative x minus 1. So here we have negative 1. Negative 1 is our y-intercept, so we have a closed circle here. So when x is 0, the point on our graph is on our line. And then our slope is negative 1. So our line would look something like this. Okay, so this is an example of a really simple piecewise function. What we're doing is we're looking at more than one type of graph, and we are piecing together parts of those graphs. So it's like we're taking pieces of these graphs and then putting them together into one single function. All right, next up, let's take a look at an example of a piecewise function. All right, so here I've written out an example from our textbook. Here we have example 1, which you can see on page 132 if you want to follow along. And we have f of x, which is defined by three different functions, or sorry, three different graphs here. So we have negative x plus 1, if x is in between negative 1 and 1, including negative 1, but not 1. we have f of x equal to 2 if x is equal to 1, and then x squared if x is greater than 1. So we're going to take a look at a few different aspects of f of x. First, we're going to evaluate a few values of x in f of x. In other words, we're looking at letter A over here. So we're finding f of 0. When we're asked to evaluate, we want to find out what part of the domain are we in so that we can identify which equation we can plug x into. For f of 0, 0 is in between -1 and 1. So that means we're going to be using our equation here, negative x plus 1. So negative 0 plus 1, that's 0 plus 1. We end up with 1 for f of 0. For f of 1, x equals 1. So our output, f of x, is going to be 2. For f of 2, well, 2 is greater than 1. So we're going to be using x squared. 2 squared is 4. So identifying which equation we should be using based on where we are in the domain. Letter B is asking us to find the domain for this function. So we can see that f of x is defined when x equals 1 for any x values greater than 1, and then any x values less than 1 but greater than or equal to -1. So we know that it goes on into infinity to the right, but to the left we reach -1, and we have the or equals to, so we include -1, but there's nothing for this function, no output defined to the left or less than -1. So our domain is going to be x values such that x is greater than or equal to -1. So any x value greater than or equal to -1 works out for our function. Okay, so next up we're looking at a graph of this function. We'll start off at the top. So first we have negative x plus 1 if x is in between -1, including -1, and less than 1. So if we look at -1 on our graph in the top right here, we could plug in -1 to find where the output would be. If we plug in -1 here, we get -1, which is +1 plus 1. We get 2 for our output. So we have a closed circle here because it's an or equals to. Then we see that we continue until we reach 1, not including 1, on the x-axis. And we can tell that this is a line with a slope of -1. So basically our graph keeps going down until we reach 1, and then we have an open circle at 1. So not a great line, but this is the graph in between -1 and 1. We have a line here. Okay, then we see when x is equal to 1, our output is 2. So we have a point at 1, 2. And this is a closed circle because it's equals to. Finally, if if x is greater than 1, then f of x is going to be x squared. So x squared, let's see, when x is 1, x squared is going to be 1. So our output 1, 1 is an open circle. So saying our output when x is equal to 1 is not x squared, but anything to the right of x equals 1 is x squared. So anything to the right is that parabola from x squared. And this parabola should probably look more like that. Okay, so here we looked at different parts of the domain, split it up, and then for each part we graphed the equation that was given to us, keeping in mind those endpoints. So those endpoints are really important, whether it includes the equals to or if it's strictly less than or greater than. All right, finally, we are asked to find the range for D. So as we can see from our function, if we look at our range up and down, here, if we look at our first equation, our function gets close to an output of 0, but doesn't actually have an output of 0 because we have an open circle there. So we know that our range, f of x, is going to be greater than 0, but not equals to. And then we see that anything greater than 0, we actually reach all of these positive values because to the right, our parabola keeps going up and up and up into infinity. So that means f of x is greater than or equal to 0, and then there's no restriction to the right or on top of f of x. So this can just be our domain here. So f of x such that f of x is greater than or equal to 0. So this was a quick example of how, when given a piecewise function, how we can graph that function, evaluate a few different values, and then look at domain and range.